almost to the end. Exam 2 review. We're on problem number 4 out of 5. And it looks like we got ourselves a truss. Okay? Find the force in members AB, AD, AE, and BD and state whether they're in tension or in compression. Remember, there's 2 ways to solve truss problems. The method of joints and the method of sections. Or for this problem, how about the combo method? How about we use a little bit of both, okay? I like the combo method on these tests for you guys because it tests both skill sets, okay? So let's first highlight what we're looking for, ABAD, okay? So that's this guy and this guy, and AE and BD, AE and BD, okay? So right off the bat, I am seeing my cut line for the method of sections. I think I cut it right through there, don't y'all? Okay? I think I cut it right through there. So step 1, find global equilibrium. So let's do that real fast, okay? So global EQ. All right, so here we go. And what do we have here? We have a normal force over here, so a GY, and then this is a pin connection. So we're going to have, let's see, FY and FX. And you might ask yourself, okay, how'd you get those directions? Well, I know FX has to go to the left because that goes to the right, right? But look at this guy. This guy is trying to rotate this whole system like that. This guy is trying to rotate that whole system like that. And so this has to pull down to keep it from like flipping over, right? And so at least that's what's in my mind. Now, if I guessed it wrong, I'll just get a negative, so no big deal. So FX, I already know, is 15 kips, okay? 15 kips, gotta be, because some force of the X, right? Now, I just don't know these other 2, so let's take the moment at F and figure it out. Okay, so what do we have? If I take the moment at F, I got the 40 rotating me positive times 15 away minus GY times 20 away. And then I've got this 15 up here, which rotates me negative, right? Wait a minute. I did that backwards, didn't I? The 40 rotates me clockwise. He's negative. The GY is positive. Woo! And then the 15 also negative. Okay, there we go. Minus 15 times perpendicular distance, 6 plus 4, 10. I could hear y'all screaming, "You're getting it wrong, you're getting it wrong." I'm like, yes, I am. All right, let's see what GY equals. All right, so it's 150 plus 40 times 15 equals 750, and then divide that by 20. So GY is 37.5. Which means that FY, right, up stuff has to equal the down stuff. I've got 40 going down, okay, and this guy is 37.5. So that means FY, oh, it does have to go up, doesn't it? But just barely, right? Because 37.5 plus 2.5 equals 40. Okay, so that's 2.5 kips. All right, round down here, okay? So we needed that. That's step 1, if you remember kind of our recipe for solving these. So step 2 is cut through the members of interest and then draw that free body diagram. So let's do that now, which would be, you can draw the left or the right, it doesn't matter. I think I'll do the left. Okay, so I have this. Okay, I have that triangle, and then I have a force there, a force there, and one here. Okay, here's DE. This is AD, and this is BA. And then this down here, I've got 2.5 kips. I've got over here 15. And then, of course, I've got 15 down here at the bottom. Okay, I think before we get going, we should figure out a couple of angles real fast. Okay, so how about this? That's 4, and then from there to there is 5 plus another 5 is 10. Okay, so I think we can figure out like this angle right here, which is the same as this angle right there. So that's opposite. 4 divided by 10 equals inverse tan of that is equal to 21.8 degrees. Okay, so this 21.8 degrees. And then we could get this angle here as well. As a matter of fact, that angle is the same as this, which is 5 here and 6 here, right? So that angle right here is 6 divided by 5, and then inverse tan of that is 50.19 or 50.2, which is the same as this angle here. Okay, so just getting some angles real fast is going to be super nice. Now, I always tell my student, I'd love for you to have one of those little clicky pens, right, that has the red and the blue and the green, so that you can make your angled vectors into components and you can see them very clearly, okay? So this guy is going to have 2 components, one there and one there. And this guy is going to have 2 components, one there and one there. And you'll remember with the method of sections, I guessed every one of those guys in tension. I just guessed them in tension. So I'm totally relying on my math to tell me if I got it right or not, okay? So, how do you do this? What are you going to get first? Well, I'll tell you what we can do. What's the easiest thing to do? The easiest thing to do. You know what I think the easiest thing to do is? Without having to calculate a whole bunch of wacky distances here, if I take the moment here, okay, if I take the moment at point D right here, then I am going to knock out 2 of my unknowns and only leave 1. But then I've got to like calculate what that distance is, and maybe that's not hard. Well, it's not hard because it's just flat out given, isn't it? It's not hard at all, it's given, okay? What is an alternate you could do? You know what you could do, okay? You could take the moment about that point, about point A, right? And it would knock out both of those guys. I don't know, let's try it. Let's try it, see what happens. So sum of the moments at A, okay, what do we get? When you take the moment at A up here at the top, that's gone, it leaves DE, right? Which rotates me positive, times how far is it from A to down here at D? This distance here is 8. Okay, and then I got the 2.5 that rotates me negative. And how far is that from point A to E is 10. And then the 15, let's see, the 15 rotates me also negative, minus 15 times that distance, which is 6 plus 4 is 10 plus another 4 is 14. And then the 15, which rotates, positive. So plus 15 times how far is that from here, right, up to A is 4. Okay? So let's see what we get. Let's say we get 25 plus 15 times 14 plus, minus 60 over there, right? It's 175, and then divide that by 8. And so DE is equal to 21.875. And it's positive, which means it is indeed in tension. These are in kips. Okay, there's one of the four things that I need, right? Now I can come back and write the sum of the force in the x and the y and get those other two things I need. So in the x direction, we have, here's DE by himself, so 21.875 plus AD cos 50, 50.2, right? Plus BA cos 21.8. In the x direction, anybody else? Net minus 15 plus 15. That's gone. Okay, so let's simplify that a little bit right there. So and one of those is backwards, right? Plus equals 0. No, thank you very much. Okay, the cosine, golly, where's cosine? Cosine of 50.2, that is 0.640. So AD 0.64 AD, right? Plus, what's that guy? Cosine of 21.8 is 0.928. 0.928 BA equals negative 21.875. And you might ask, what are you doing there? Well, I'll tell you what I'm doing. I'm getting this set up for two equations, two unknowns in my handy-dandy system solver. Okay, here we go. Sum of the forces in the y. Okay, in the y direction, what do we have? We've got AD sine. Okay, so AD sine of 50.2. Okay, going uphill, I've got BA sine of 21.8. And then who else is in the y direction? That guy, plus 2.5. Okay. All right, one more time, I'm going to make equation number 2 here. All right, so the sine of 50.2 is 0.768. Plus the sine of 21.8, 0.371. And then minus 2.5. Okay? So, there's equation 1, equation 2. Let's put that in our system solver, and then we'll have all the answers. Okay, here we go. 0.64, enter. 0.928, enter. And then, what did I have over there? Negative, 21.875, enter. Next one, 0.768, enter. 0.371, enter. And then finally, negative 2.5, enter, and then solve. And I get this. I get AD is equal to 12.19. And I got a positive answer. So AD, I drew in tension, so he's really and truly in tension. Okay. And then the other one, which was BA, I got, negative 31.98. So I'm going to put 31.98 kips. But I got a negative, I drew him in tension, so he's really in compression. Okay? So there's 3 out of the 4 that I got. I got you, and you, and you. Okay? So how do I get that last one, which is this guy right here? Well, how about we just do this? A little method of joints of joint B. Joint B looks like this. It's got one going straight down, one going like that, and one going like this, and then 15. Okay, so let's see. This one down here is BF, boyfriend, And then this one over here is BD. This is BD. Ooh, but we know BD, don't we? No, we don't. No, that's what we're looking for, isn't it? What about that top guy? That's BA. That's BA. Oh, that one we know. That was 31.98. Okay? And 31.98 is in compression, and what do compression members do? Do they pull on the joint or do they push on the joint? They push, right? So there you go. Boop, boop. So, I don't know. I got something left. I got something right. I got ups, downs. I don't know. I'm just going to guess these two guys' intention. Maybe they are. Maybe they're not. I need BD. What am I going to do to find BD? Sum of the force in the X, because guess what? BF doesn't have an X component, so he will not be in that equation. So I am one equation away from that final answer. And all I need is the angle, don't I? That's all I need. So this angle here is 21.8. So I need this angle down here, okay? I need this angle right here, okay? So I can do that by saying that this height here is 4, and that's over there is 5, and so that angle right there is 4 over 5. 4 divided by 5, clear. 4 divided by 5, inverse 10 is 38.6, I'll call it 38.7 degrees. So this, 38.7 degrees. Okay, we're done, right? Sum of the forces in the X equals 0 equals 15 minus 31.98 cos 21.8 plus BD times the cosine of 38.7. All right. So, let's see what we got. 31.98 times the cosine of 21.8, and then minus 15. Okay, it's 14.69, and then divided by the cosine of 38.7 equals, drum roll please, BD is 18.83. Kips. And I got a positive answer. I drew him in tension, so guess what? Bam, he's in tension. So there is my final answer. 1, 2, 3, 4. The combo method. Method of sections, method of joints. Man, we're kicking it up a notch in here now, right? One more review video and then we're on the rest of the class.